Okay. So this was a query I gave at the end of class, so I just want to write it down. Okay, so that's the relational algebra query. Um, so any questions on this query? So I'm still going to keep the keep both the documents open, even though it gives me less space to write. Just because in order to do these queries, you will need to look at the schema. So I'm going to keep it open. In class, I would have handed it out to all of you, but since I can't do that, we'll just have to do the best we can with this. So list the female dependents and their birth date. Can you try doing that? So I'm going to give you a couple of minutes to do it. Okay, so did anyone has any question on this query? So for this one, you had to look at the dependent table, and the output would, the attribute names in the output would be exactly the attribute names that are in the table dependent. But suppose you wanted to change the attribute names. So suppose you wanted the output to look like this. Okay, so suppose you wanted your output, instead of being dependent underscore name and B date, you wanted it to look like this. You can do that. And that is the next operator I'm going to talk about, which is the rename operator. And the rename operator is called row in relational algebra. So if I wanted to rename, the way I would do that in relational algebra would be, so it's a kind of messy, but I'm going to try. So row underscore result, and then you write down the attribute names. And then the rest of it, you just write down the same query that you just wrote. So oh, sorry. So you just write down the rest of the query out here. And I mean, I don't have enough space, so I'm going to have to, and then you put a parenthesis around that. So, so that's how you do the rename. You write it down, you write the query, and then you write down the table name that you want, and then the attribute names, the new attribute names in there, and then you'll get this output out here. So that is the rename. I just want to give a little more of the syntax of rename. So it is, so rename as so this is the new relation name. These are the new attribute names. And this is the old relation name. Oh, I wonder what this noise is. I'm getting some noise here. Okay, so, and if you didn't want to rename, you just wanted to rename the table name, you can do that too. You just, you could just say row S R. So then the column attribute names will stay the way they are, but the table name has changed. So for example, employee is a rather long name, and instead of using employee, you wanted to shorten it. You could do emp, you can just do that. And if you, all you wanted to do was you want to leave the result, the table name the way it is, but you want to change the attribute names, you can do that too. You could do that's okay too. Um, so like, so the same query that, you know, where, I'm trying to see. So let's say this query, if I split it up into two, and instead of having, so this particular query, suppose I wanted to name it as last name and salary. I just want to show you a different way of doing it. I mean, and I think I did it in the last class. You can divide it into two different queries. So you could do temp So you can do it like this in relational algebra. So just before I move on, I mean, that's it with rename. It is a very useful command. I just want, in relational algebra, the tool that is up there, the rename of a table, it only lasts um, you know, it doesn't last for the entire session of relational algebra. The rename will only work for that particular query. So you cannot use, so if I wanted to change the employee table name, which is rather long, to M, and I wanted to last the whole session that I'm, working in the relational algebra tool, I can't do that using the rename command. It'll only last, the rename only works for that one particular query. So if you want to rename a table so that it lasts the entire session, and it is kind of convenient, it's a bit of a pain having to type employee each time. There is another command to do that, and this is only for the tool. I just want to mention it as a sidebar. So, so Um, so here you can use the views thing in the tool. So, I think that this is where you do it in the relational algebra tool. You have RA. So that's the prompt when you get in the tool. So just say EMP. So after that, if you want to list the employee table, you can just write EMP. It'll work for the entire session. So, so use this if you are, working in the tool. So I was trying to, doing the assignment. On the other hand, when you are submitting all these queries, I would recommend, I guess, because you're submitting it into in a file, it should work even if you use the rename. I just wanted to figure out. Let me just think about this. The main thing is because Shihong is going to be grading everyone's in one shot. If you rename something with your query, and then you don't reset it, it might create a problem. So I need to think about this one. I just want to think about this view part renaming when you submit as an assignment, just because the TA, when she grades, I just want to make sure it doesn't run into a problem. But anyway, this, other than that, I mean, the view thing is actually really convenient. It shortens names of tables. So any questions?
I have a syntax question for the quiz. Are we going to be given instructions on how to type this out?
Yeah, so that is one of the big problems with the relational algebra tool. In fact, I think that was the reason last year I didn't give a midterm exam, because I couldn't figure out how to type these pi and sigma, all the relational algebra stuff on the on Canvas. I know how to do it on LaTeX, and which I give out in class, but I don't know how to do it on the Canvas, and I still don't know. So I've got to somehow figure this out between now and Wednesday. I'll figure it out after the class today. I'm going to try to see how to do this. But anyway, I'll figure it out, and I will, whichever way you'll be able to do it. If I can't figure it out, I mean, I'll have to think of a solution. I didn't have to deal with it last year because the school closed at the spring break time, right? And at that point, the only thing that was remaining was the midterm exam. And so there was no time. So I said, okay, no midterm, and only because of relational algebra, actually, because I couldn't figure it out. So I'll try to, and like I said, so far I haven't figured it out, but I will sit and work on it today. So, so you'll have the answer at that time. I don't have the answer right now, but I'm going to figure something out. Anything else? Everything else was fine, SQL and everything else. It was just the relational, these sigmas and pi's and unions and joins, and that was really hard. I mean, I didn't have a solution to it. So I'm going to ask around after class today and see if anyone else, any of the other faculty had to deal with, and maybe the person who teaches database, no, actually to the IT, but in the IT, they don't actually do relational algebra, so I guess they won't have a problem. So anyway, I'll have to think about it. So, so anything else on rename? Okay, so then the next thing that, the next few commands I want to talk about are going to be the binary that operate on two tables, because so far we did sigma and pi, and actually row too, and they're all on a single table. So now I'm going to talk about the union, the intersect, and the difference. So it's all on two tables. So this is the restriction, is that all of these operators, they there must be identical attributes or in both the tables. So I'm going to explain this, but let me write this down. They must have so the tables on which you do, they must have identical attributes, and they have to be in the same order, the attributes. So otherwise this won't work. You will get an error. So first, I just want to give an example. That is simpler than the company database. So let's say we have a student table. With just one attribute called student name. Okay, so we have there are three students. So we have Adam, Jim, and Mary. Okay, so the table has 3 rows, Adam, Jim, and Mary, and we have a second table called instructor. And instructor has also just one attribute. So let's call it iname. And we have 3 in. Let's keep a small table. So we have 2 instructors, Adam and Dana. Okay, so we have okay, so we have these 2 tables, the student table and the instructor table, and there's just one attribute in both. So we want to look at student union instructor. So that would be okay. So now when you look at this, you know that student union instructor would be, Adam, Jim, Mary, and Dana. Those are the output of this. So you're going to have, but in relational algebra or in MySQL, what happens is that the attributes have to be identical. and the attribute names have to be identical. The type has to be identical and everything. So here the type and all is identical. They're both of type string, maybe length 20 or something. But you have S name on one and you have I name on one, and that will give you an error. So it has to be name out here. It can't be S name and I name. So otherwise you'll get an error. So student union instructor is just the output of that is just going to be, let's say name, and then you have so that's the the thing with relational algebra and SQL is that the names have to be the same. And if I wrote this down in relational algebra tool, it would be you would have to rename one or the other. So I think I would do it in this form. It would be union, and then I should rename maybe the instructor one, I should rename it to S name too. So in this case, it'll come out as S name, not his name. There'd be an S also out here. So that would be the output of this. So similarly, you have to do student intersect instructor. So the output for that is going to be, again, you have to rename it. So it will be just Adam. Um, student minus instructor, Jim and Mary. So we're going to have and then the last one is instructor minus student. So it's going to be Dana. Okay, so that's and of course they must all have head, you must, I forgot to put, you must have it, there must be a name on top. Okay, so those are the operators. So they pretty much work exactly like this in relational algebra. So does anyone have any questions before I start doing queries that deal with the company database? Do you understand all of these? Okay, so list the social security number of employees who have no dependents. So I want you to try out this particular query. So here you are looking at two tables, the employee table Actually, don't. You could also just look at the dependent table because it has social security numbers out here. So list social security numbers. So just try this out. The one you have to think, can you do it with just this one table or do you need both these tables? Okay, so so were you able to do it just using the dependent table or do you need to use both the employee and the dependent table? Anyone?
I think
You
you have to
need to
use
use,
both.
yeah,
And which
you need to use,
operator did you use if even you use both?
What, sorry, say again.
Which operator did you use? Union, intersection, minus, or difference? Yeah, which one did you
The
use?
difference, yeah, minus.
Yeah, so that's right. You have to use both. So so the output of, I mean, this is the way you'd be doing it. Pi of, okay, so any questions on this particular one? So here you would have to rename because it's ESSN, so you'll have to change it to SSN. Okay, so list the projects, that is the project number, PNO of that are common to employees 1, 2, 3, 4 and employees 3, 3, 3, 4. So first 4 digits I've taken. So we have to look at this particular table. You have to look at the works on table. So the projects that are done by employee 1, 2, 3, 4. So 1, 2, 3, 4 is working on projects. So under the works on table, it's working on projects 1 and 2. And 3, 3, 3, 4 is working on projects 2. So I want you to do this particular query, try out this query. Okay, so I'm going to write down different ways. I had to remove the other one from the screen because I need to write, this query is kind of long and I can't write it in such a small space. So I'm going to write down several ways, and I want you to look at all the different ones and see which of these or all, I mean, how many of these are correct. So my first attempt is, so this one is the OR operator. So I'll do the same thing with the AND operator. Okay, so I've written down several different possibilities. So what do you think, anyone? I mean, do you think they're all correct? Some are correct?
Some are correct.
Which one?
First two won't work out.
Okay.
And I think both 3 and 4 will work out.
Okay, let me just write down. So according to, so I don't know who it's, because it's being recorded. I don't even want to mention names of the students. I'm not sure who's talking. So, so I'm not going, but so you said that the first two are wrong and the third and the fourth are correct, right?
Yep.
So anyone else wants to jump in?
I think the fourth one is wrong because it's going to be intersecting on all the columns of data. So if even one column
good
of
call.
data is different, it won't be an intersection, even if the project numbers match.
Okay, yes, I
Good
heard
call.
what you just said. Yes. So according to, so what you're saying is that this one's also wrong. So now it's that the 1, 2, and 4 are wrong and the third is correct? Is that
Yeah, that looks good.
okay? Is anyone else? I mean, other than these 4, is there anyone else who came out with some other solution that I could write down out here? So, so the thing is that, so this is only the third one is correct. 1, 2, and 4 are all wrong. So the question is that is what would be the output of, let's say, 1. Let's look at 1. So that's why I put the table down out here. I know it's really tiny, so I don't know whether you can see it on the screen and in your on your machines. Yeah, but would anyone tell me, like, why the first one, what would be the output? I'll see if I can go back to the double screen, because now that I wrote down the queries, it's should be okay. Oh, it doesn't matter. How do I bring the two? I keep forgetting. Okay, let me just pull it back, sorry. Yes, so what would be the output of the first one, which is sigma ESSN is equal to 1, 2, 3, 4 or 3, 3, 3, 4?
It would be all projects that either 1, 2, 3, 4, 1, 2, 3, 4, 4 work on, but not the shared projects.
Yeah, that's right.
Not the shared projects, sorry.
Yeah, you're right, because all the output that we really want is just this 2. That's the only one that's common. So what we are looking for is a table with just 2 on it. So, but if you do this very first one, what you're going to get is you're going to get all 1, 2, 3, 10, and 20 for the first one. So what about the second? Oh, sorry.
Oh, no.
What
I
is
was
that?
going to ask if there would be 2 2s, but then I realized that would be the key, so you can't have doubles of keys.
I didn't get that. Can you just repeat that question again?
I was wondering if there would be 2 2s because you're doing selecting from, I don't know, never mind.
Yeah, the thing is, they remove in a relational algebra, it'll remove the duplicates. So it'll only print out 1, 2. But if it was MySQL, it might print out 2 2s. So if you're talking about the same entry 2 coming in twice, right?
Yep, I see now.
Yeah. So what about the second one? What would be the output of the second one?
Nothing, because it's a contradiction. You can't have the ESSN be both 1, 2, 3, 4 and 3, 3, 3, 4.
Yeah, you're right. That's a very good answer. So you're right. There will be no output for this. For this, you're going to get no output because it's an empty. You're not going to get both 1, 2, 3, 4 and 3, 3, 3, 4 in the same row. So you're going to get no output for the second one. So does that make sense to everyone that there would be no output in number 2? Because there are no rows with ESSN is equal to 1, 2, 3, 4 and 3, 3, 3, 4.
So would that output like an empty table, basically?
Yes, it'll be an empty table. You'll
Okay.
get output. So that's the second one. And so this one is correct, the third one. So let's look at the fourth one first. Okay, let me just show the third one, So the output, the third one is correct. And this is, and so the textbook sometimes shows these kind of diagrams. They are kind of useful, to kind of understand what's going on. So they show a tree diagram that this is what's happening, and they're actually quite useful for complex queries. So this is the works on table. And then what you're doing is you're doing sigma . And then you're doing a pi of it. And then you're doing the intersect. So that's the number 3. That's what we're doing in number 3. So in number 4, what would be the output in number? So this is number 3. If you drew the I think I don't know what they're called really. It's getting out of my head. I think it's called the tree diagram. So they kind of make it, and it is kind of it kind of shows you what's happening. So what about the 4th one? I'll just move this down a bit. Okay, so number 4. What about this query? What would the output of this query be?
This one, as pointed out, would be an empty table again.
Yeah, you're right. This is going to be an empty table. You're not going to get any output for the same reason as the earlier one, where you get no output because you're doing an so I mean, again, if I drew the tree diagram for this one, this is going to look like this. So this is pi p and o intersect. Okay, so what happens out here? So if you look at this and the previous one, the difference between this diagram and the previous one is really the fact is that here we do a pi PNO first before we do the intersect, while here we don't do, we first do the intersect and then we look at pi PNO. And remember, intersect has to happen on identical things. So for example, the output of this part, what we are trying to do, the intersection is going to be for sigma ESSN is equal to 1, 2, 3, 4, the output would be all the rows with, so that would be 1, 2, 3, 4, 132.5. And here you're going to have 3, 3, 3, 4, 3, 10.0, or 2, 10.0, and so on. So if you try to intersect this table and this table, it's an empty. There's nothing common between these two tables. So that's the reason that you first have to do the pi so that you bring that one attribute that's common and then do the intersect of the two. So is that making sense to you? If it doesn't, just try it out. I know that sometimes when you start doing it, it is a bit confusing. So I really recommend that if this part that I just explained is not clear, just try it out on the tool and work it out. So so remember, there is a quiz on Wednesday, and like I said, I'll figure out what to do with the so you won't have to deal with it. I have to figure out how to set up the quiz online. But